So today we're talking determinants, you guys. The goal is to calculate determinants. What's the definition of the determinant of a 2x2 matrix? 2 rows, 2 columns. So here's the definition. It's really straightforward. You have a matrix with entries, say, A, B, C, and D. The determinant is what you get. It's a real number, and it's what you get when you take A times D and you subtract off B times C. So it's what you get when you do this. A times D minus B times C. And this is a good time to introduce a more sophisticated way to write the entries in a matrix. A more sophisticated way to write it, a 2x2 matrix, if you call it, say, matrix A, then you could denote the upper left-hand entry by a lowercase a and then a subscript 1, 1. Not 11. If you read it separately, separate digits, 1, 1. So the subscript would mean, A1, 1 would mean the first entry in first row, first column. So the entry, so the 1 would be the row, the first one would be the row, the second one would be the column. So what would you call the second entry in the first row? What would the subscript be? A1 for the first row, but it's the second entry. Does that notation make sense to you? And then could you fill out the second row for me? What would that be? A2, 1, because it's the second row, first entry, right? In the column. Second row, first column. And then what would the last one be? A2, 2. Okay, so keep that in mind. In this notation, then, what would the determinant be? It would be well, if we go from here to here, A1, 1 times A2, 2, right? Minus what? I suppose the order doesn't matter, but A1, 2, if I keep the order that I used up here, what's acting like B is A1, 2, and then times A2, 1. Can you guys tell me what the determinant of the matrix 1, 2, and then 3, negative 4 would be? Here's the notation. You'll see the vertical bars. It looks just like absolute value notation, but in context you know the difference because the capital A stands for a matrix. So this means the determinant, vertical bars A inside, means the determinant of A. But you'll also see DETA. In fact, your calculator uses that notation. Can you guys compute that for me? What would that be? Negative 10. How'd you get it? Yeah, so you'd have 1 times negative 4, right, for this first multiplication. Second multiplication minus 2 times 3. So that would be a negative 4 minus 6. Negative 10. Okay. So find the determinant of A using this notation. Tell me what would that equal. What do you get? That's what I got. What's the thing that could possibly trip you up? So I think this part's pretty straightforward, right? Negative 2 times 4 is 8, negative, right? Negative 8, and then if you're not careful, by definition, there's a minus after that, negative 8, right? But when you take negative 3 times 5, you get another negative. And so you end up with negative 8 plus 15, which is positive 7. Do you think it's as easy to find the determinant of a 3x3 matrix? No, it's not. It's several times lengthier. There's a definition, though. And there's a lot more behind this definition than what I'm telling you, but you have to take a more advanced class to get the real definition of a determinant, which involves permutations and weird stuff like that. But the definition, the thing we're going to call the definition is that, well, let me just show it to you, and then I'll write it down, because it'll be easier to understand the definition, the general formula, after I show you how to do it on one of these. So we have this matrix A with rows 1, negative 3, 2, 3, 1, negative 4, and 2, 3, 6, and we're going to find the determinant of this thing. So the way we do this, we're going to expand about the first row to find this determinant. So here's the process. It's going to look strange at first, but after you do it a couple times, you'll get pretty good at it. It just takes time. So to start, circle the first entry, first row. And at least, now I don't know if you want to do this on paper every time because it gets a little messy, but at least in your mind, cross out corresponding column, corresponding row to that one. Okay? And then notice that there's a submatrix. It's a 2 by 2 submatrix. 1, negative 4, 3, 6. And we're actually going to, the determinant of A, the whole matrix is going to involve the determinant of submatrices. So we're going to write down that submatrix in determinant form because we're going to take the determinant of it in the next step after this one. And in front of that matrix, so that's submatrix 1, negative 4, 3, 6, I wrote down right here, and then I put the vertical bars down to indicate I'm going to take the determinant of it. And then I'm going to multiply that by the thing we circled, the 1, which won't do much here, but I need to put it there for cases where it's not 1, right? Now, by definition, just like with the definition of a 2 by 2 determinant, by definition, there's a minus here. So when you wonder where it comes from, it's easy to answer. It's a definition. We say it's there because it's there. It's a definition, right? Now, you're going to move along the first row. And so now you're going to, let me erase that extra stuff. Now you're going to circle the negative 3, the next number in the first row, cross out corresponding column, corresponding row. And do you see the submatrix that's left there? So by the way, I'm going to write down that negative 3 in front. So the thing I circled, write it down. And then do you see the submatrix that's left over that's not crossed out? 3, negative 4, 2, and 6. Everybody sees where that's coming from, right? Then you scoot along to the 2 in the first row. Let me erase this stuff because it's easier to erase. And then scoot along to the 2, cross out corresponding row, corresponding column, and you're going to add in, by definition there's an addition sign here, you're going to add in twice that number 2 times the determinant of the submatrix that's left over that's not crossed out. What's that matrix going to be? 3, 1, 2, 3. Okay. You do that calculation, and that's it. That's the determinant. So this is called expanding about the first row to find the determinant of A. So the notation, vertical bars A, that means determinant of A. And that's it. We still have to compute it, but that's it. That's the definition I'm going to present to you. So we have to compute 3 2 by 2 determinants. Okay, so what would this first determinant be? 18. Yeah, I suppose we should show our work here. So 6. Okay, it'll be minus negative 12, so it will be plus 12. But keep in mind, I skipped a step there. It's minus a negative 12 is what it is. Does everybody see how I got that? I'll fix that in the next step. Minus negative 3, that's plus 3 times, what's the value of this middle determinant? 7. So let's not do it all at once. Let's show the work. So 18, right? 3 times 6 is 18. Minus negative 8, right? Yeah, you know, I'm rethinking that. I better show that. Until you're used to the definition, I better show everything. Otherwise, you might think it's a plus there when it should be a minus right there and right there, right? So normally I would simplify it a little bit ahead of time, make it 18 plus 8, but for the first example, I'll leave it and simplify it as we go. Okay, and then any questions on that? And then plus, okay, look at this guy, 2 times, what's this last determinant? Without you know, just show me the multiplication. What would it be? So it would be 9, 3 times 3, 9, minus 2, right? Yeah. And everybody makes that mistake for whatever reason when they first start learning about determinants. You got to know where the minuses go in the definition of the 2 by 2 determinant and the 3 by 3. Any questions there? Okay, so this is going to be what? 18, 6 minus negative 12, 18. And then this is plus 3 times what, 26? And then this is what, 2 times 7? What does that turn out to be? It does. Turns out to be 18 plus what, 78 plus 14. If you do that calculation, it does turn out to be 110. So right about now you're thinking, wow, who cares, right? But this stuff is used for other more advanced math, so that's why we care. Anyway, that's the determinant. And let's then talk about a general definition for what we just did. So definition of a 3 by 3 determinant. Okay, so the 3 by 3 matrix determinant definition. To each entry in a 3 by 3 matrix, there corresponds a 2 by 2 submatrix. For example, the matrix associated with A12 in the above example. Okay, which one's A12? Which entry is A12 in this matrix? So it's first row, second column, right? That's the negative 3. So the submatrix that corresponds with that negative 3 is what you get when you cross out corresponding column and corresponding row with A12. Cross out the row and column that correspond to A12, that correspond to that negative 3 in this case. And so what's the submatrix that we're talking about then? 3, negative 4, 2, and 6. And so that's exactly the matrix we had here in the middle from when we first showed you how to calculate a determinant. The determinant of this submatrix is called M12. So the determinant of this submatrix is called M12, where M stands for minor. So tell me what the minor is associated with this submatrix. What is M12? It's 3, negative 4, 2, 6, which we know from above is 18 minus a negative 8, which is 18 plus 8, or the 26th. Then what would M13 be? If you look at the matrix, what is A13? Okay, what number would I circle in the first row? A13, first row, third entry. So what submatrix are we talking about? 3, 1, 2, 3. 3, 1, 2, 3. But when you see M13, we're talking about the determinant of A13. And what did that turn out to be? That's the 9 minus 2, which is 7. Okay? So then, using the minor notation, we can give you a generic definition of a determinant of A. That's the point. So if you think about it, then what did we do above generically? Well, to begin with, we circled A11, right? The first entry in the first row. And then we multiplied that times the determinant of the corresponding submatrix, which would be M11, right? So that, just to make sure you're following me, that would be this one, right? There's A11, and then we're multiplying that times the determinant of the associated submatrix. Is everybody with me? And then minus, by definition, we went to the next number over in the first row, which is A12, And you had to multiply that times the determinant of the submatrix associated with A12, which you crossed corresponding column, corresponding row out to get. That would be called M12. And then plus, what would the last one be? A13 times M13. So the symbolism is just so that we can write down a symbolic definition of the determinant. So in terms of expanding about the first row, the determinant of A is that thing, A11, M11 minus A12, M12 plus A13, M13.